Hey everyone, Mr. Skelton here. We are back at it, starting lesson 4 in Unit 8, and today we're going to be talking about summation notation. Good news is, lesson 4, it's the same thing, or it's a combination, I'm going to say combo, of lesson 1, which is arithmetic sequences, and lesson 3, arithmetic series. Today what we're going to be doing is writing arithmetic series with using summation notation. What does notation mean? It's just a different way to express something, right? Write something out, notation, write something out, express something. So it's called summation notation, we'll talk about it. But if you look at the learning target, I can express an arithmetic series, that's what you did in lesson 3, that's where we find and add all of the terms together, find the sum. So you already know that formula using summation notation. Also, I can find a term, any term, using the explicit formula. That's what you did in lesson 1. So we're going to be focusing today on the arithmetic series, which means we're going to be using the explicit formula for that. So again, it's a combination of 1 and 3. Okay? So let's just jump right into it and take a look and start talking about summation notation. This is what it's going to look like right here. This is the Greek letter for sigma, okay? And this is what represents summation notation. So you're going to get something like this, and you're going to have to find the sum. Because remember, all we're really doing is what we did in lesson 3. You're going to be finding the sum. So that's what I'll get down here. It's an arithmetic series. That's all you're doing. And if you remember, that formula was this. You take the total number of terms, divide by 2, you take your first term, and you add it to your last term. Remember, a sub n is your last term. That is what we are doing today. Okay? We're just starting a little bit differently. We're starting with something that's in this notation. Now, what does this mean? What does it look like, and what does it mean? Obviously, what it means is we're finding the sum, but let's talk about some things. This is what we call the lower limit. You're going to hear that word as you rise in your mathematical career. It's basically where you start. Okay? That's where you start. This means your n equals 1 means you're starting at term number 1. That's where you start. Okay, term number 1. The top number is called the upper limit. And if you start here, that means you're going to end here. So we're basically going term number 1 all the way to term number 4. Okay? That's what we're doing. This right here is important. This is always the explicit formula. And in this case, since we're doing summation notation for arithmetic, this would be the explicit formula for the arithmetic sequence. Okay? So let's take this and put it into practice. I think on the back. Nope, I don't have it. We'll just stay right here. Let's stay right with this one. Okay? Let's make we'll find a little space down here at the bottom and make it work. So when you have something in summation notation and you're asked to find the sum, which is what it's going to say, find the sum. That's what an arithmetic series is. What I always like to do is I want to first start out by writing out the first few terms. So I don't know what my first term is here, so I need to plug a 1 in for n. So 3 times 1 is 3. 3 plus 5 is 8. So my first term is an 8. My second term, what would my second term be? Well, n would be 2. 3 times 2, 6. 6 plus 5, 11. If you need to go 3, maybe go 3. 3 times 3, 9. 9 plus 5, 14. So I want to create a sequence. Some of you won't need to do this, but I like to. And then I am saying, okay, what am I doing here? I am adding 3. Perfect. Okay? So if I want to find the sum, which remember is this, what do we need? We need the first term, we need the last term, and we need the total number of terms. So if I start to fill in with this formula, I know I have 40 total, because remember that's my upper limit, over 2, times my first term, which is 8, plus my last term, which I don't know. So what does that mean? That means we got to find out what the 40th term is. So how do we do that? Well, we got to figure out what the 40th term is by plugging 40 into the explicit formula. So I can just take 3 times 40, which equals 120, add 5, so 125. So 125 is my 40th term. All right? And so I can just plug 125 in right here. And so now all I'm going to do is take my, I was going to do it a longer way, but it should make sense to you. You can go now 8 plus 125, it equals, and then times that by 20, and you should get 2660. And that is the answer to this. Okay? So I know it's a lot going on, but should make sense to you. And we're going to practice more. So let's turn the page over here. Okay? I honestly hit pause and try both of these, see what you can do, and we'll come back together and give it a shot. Okay, so it says find the sum. It's in some summation notation. If you would like to, if you want to write out the first few terms of this, we plug in a 1. 1 minus 1 is 0, right? 1 minus 1 is 0. 0 times 6 is 0. So all we'd be left is 15. So my first term is 15. Let's plug in a 2. 2 minus 1 is 1. Times 6 is 6. 6 plus 15. My second term is 21. Now with this, you can kind of see what's happening. You'll notice that with this one, we didn't have the n. Oops. With this one, we didn't have the n minus 1 part in here. This one we did. I just kind of wanted to show you some variations of it. I could have easily distributed this 6 through if we wanted to. But when I look at this, I know I'm starting at 15. My common difference is 6 because I'm adding 6 n minus 1 times. So I already know I have this kind of situation happening where I'm adding 6 to get to my next term. When it's like this form, it's nice. Harder to do. That's why I wrote out on the previous one, because this one I really can't see. I know I'm adding 3 because the 3's out in front, but I like to write it out first. Okay, so at the end of the day, if we're trying to find the sum, we want, again, this formula, right? A sub 1 plus a sub n. So really what I have on this one is my total number of terms. My upper limit is 25 over 2. My first term is 15. I got to figure out my last term. All I do is take my last term of 25, my upper limit, and plug it in for n. So 25 minus 1 is 24. So 24 times 6, then add that to 15, and I got 159. So I have 159 now, plus 15, hit equals, and I'm going to times that by 25 divided by 2. I use my parentheses, hit equals, and I get a sum of 2175 as my answer. Okay? Bottom one here, find the sum. Again, because it's written like this, I can kind of decode this or take this apart. I know my first term is going to be a 7. I know that my second term is going to add 4 to that, which is 11, so I'm basically adding 4 over and over again, all right? So if I'm finding the sum, I'm going to have 28 terms over 2, sorry. My first term is a 7. My last term I have to find. Again, I find that by just plugging 28 in for n. So 28 minus 1 is 27, times it by 4, and then I'm going to add that to 7, it equals 115. So 115 goes there. I'm going to add 7 to that, it equals, and then I'm going to times that by 14, and I get 1708. So the sum of that sequence is 1708. Okay? Hopefully we're doing okay to start with here. Now we're going to get into a couple more problems. And here we go. So this says write using summation notation and find the sum. So now we're just going to see, I'm going to give you a sequence. I want to see if you can write it in summation notation. All right, so let's take and write our summation notation. I know I'm going to start at n equals 1. Do I know what my upper limit is, how many terms I have? I don't. We're going to have to figure that out. Do I know what's happening? Do I know what my explicit formula is? Not yet, but we can see that we're adding 2 over and over again, right? So I can kind of put my explicit formula together. I start with 10. I'm adding 2 n minus 1 times. There's your explicit formula. Now, I will accept this for an answer. If you want to distribute the 2 through and simplify it, you can. Most students will leave it like this because it makes sense to them from less than 1. Now, all I need to do is find out what my upper limit is. Well, I'm giving you the last term. If they ever give you the dot, 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 comma, This number right here is your last term. We need to figure out what term number it is. So we're going to go, I'll do it in black ink. I'm going to go 112 equals 10 plus 2 n minus 1. So subtract 10. So I'm going to get 102 equals 2 times n minus 1. I'm going to divide by 2. So 102 divided by 2 should be 51. So I get 51 equals n minus 1. So n equals 52. So that means my upper limit is 52. So there is my summation notation. And it also says to find the sum. I didn't leave a lot of space here, did I? Let's do it right here. The sum would be 52 over 2. Total terms over the divided by 2. The first term is 10. My last term is 112. So I already got all the pieces. Let's just figure out the math. Times that by 52 divided by 2. It equals, and I get a sum of 3172. That would be the sum of that sequence. Okay? Good stuff, good stuff, good stuff. All right. Let's carry on, shall we? Let's do this one here. Go ahead and tell me, or go ahead and write using summation notation and find the sum. Got to get the words out of my mouth. So go ahead and hit pause, try it, and see what you come up with. Okay, so you can see that we are adding 7 to each term, which is good to know. In terms of summation notation, I'm starting at my first term. My explicit formula for this arithmetic series, I'm starting at 33. What am I doing? I'm adding 7 n minus 1 times. Again, I would accept this answer. If you want to distribute the 7 through and simplify, go for it. What do you have to do? We have to figure out what the upper limit is. So in order to do that, 257 is the last term. So I'm going to take 257 equals 33 plus 7 times n minus 1 and solve for n, because I want to figure out what term number 257 is. So I'm going to minus 33. So 257 minus 33 gives me 224 equals 7 times n minus 1. I'm going to divide that by 7, which gives me 32 equals n minus 1. So n equals 33. So that means my upper limit is 33. So there's my summation notation, which is part of the answer I wanted. And then I wanted to find the sum. So to find the sum, it's the total number of terms, 33 over 2, times the first term, which is 33, plus the last term, which we just found, which we already know is 257. Yeah. So I'm going to take 257, I'm going to add 33, and I'm going to times that by 33 divided by 2. And I should get 4,785 for the sum. Okay? Last one here. I'm asking you to find the sum. So just a same type of question, just slightly different information. See what you can do, and then we'll come back and give it a try. All right. So I don't have my explicit formula written in here, so I wanted you to do that. So what's happening? I'm adding 2 to everything. So my explicit formula would be, I'm starting at 150, I'm adding 2 n minus 1 times. Okay? Now, if I ask to find the sum, sometimes it helps just to write it out. I know I have 100 terms. I know what my first term is. I need to know what my last term is. I don't have that information. Notice on these two, here and here, I gave it to you. Here I don't have it. I know I have 100 terms total, or I have 100 terms, so I need to figure out what that 100th term is, or a 100th is. How do we do that? Plug it in, right? So 100 minus 1 is 99, so 99 times 2 equals, add that to 150, it equals. So that's 348. So 348 goes right there. So now I can find the sum, 348 plus 150 equals, times that by 100 divided by 2, which is 50, and I should get 24900. So my sum is 24,900. Good stuff. Okay? So again, really all we're doing is things that we've already done. We're using explicit formulas. It's all based on arithmetic sequences. This is all arithmetic. Okay? And the nice thing is, one of the next lessons coming up, we're going to do all this same stuff, but for geometric. So we'll have summation notation for geometric. So hopefully you can see that this is just a combo of lesson 1 and lesson 3, which was series for lesson 3, and this was sequences. So it's just a combo of those two, and we're just expressing things, writing things in a different notation. All right, if you have questions, as always, be happy to help you out. Look forward to seeing you in class.